Also, while I try to get through some of the older no movement PRs I hadn't quite gotten to yet this morning.
Sure.
Oh,
It's always plenty of PRs.
I know. It's kind of I only continue to do this manually because it's the way I force myself to like go through all of the performance PRs and see what's changed.
Yeah, yeah, that makes sense. Kind of a forced scrubbing process.
Yeah, because I mean, every once in a while I think about just trying to automate this to see, have it go through and like just man or automatically figure out what's changed in the last week. But I figure it's kind of good to actually manually force myself to look at all of these.
Yeah, they at least pay a little attention to them.
Yeah. Oh boy. Well, okay. Let's get started here. We've got a couple of folks now. All right. So, new stuff for this week. Sage implemented a new minimum default for the PG autoscaler of 16 instead of 4. I think that's a fantastic idea. That 4 is just so few that you don't get a whole lot of parallelism, and it kind of causes issues. 16 is definitely, in my opinion, a much better default. Um, Whether or not we could also kind of adopt some of the things that we were talking about last week, where we shrink the PG log length so that we could even push that out further. Yeah, that's maybe a discussion for later on. This is a really good starting point, I think, but certainly more PGs and kind of more minimum PGs for better scalability or better parallelism rather.
Yeah,
I think is definitely a good way to go.
I think it'll help a lot with small clusters too. If
Yeah,
there's not
de-
much data there yet, or 16 is a much better
definitely.
minimum for even 3 OSDs.
Yep, yep. All right. Let's see. Next, we have a PR from Miha that, after our discussion from last week, disables arm range in Nautilus completely. I think that's very good. And it's Nautilus specific since I don't think we actually even have the ability to turn off delete range in master right now. So that's good. I think that probably we should just leave it off for Nautilus indefinitely and focus on figuring out where we can effectively use delete range in master for octopus. But so that's good. And then we have another PR from Jan Waller to decrease the default max OMAP entries per request. Looks like you approved that, Josh.
Yes, that's right. Yeah, the current default was just crazy high, so it makes sense to put it much lower and try not to overload the OSDs.
Do we have a kind of a good sense? Is that like something that we can reasonably have like a static default for, or does it kind of depend on how fast the database device is, do you think?
It depends a little bit on how fast the device is, but it's more, I think, usually CPU bound, oftentimes.
Oh,
Um, and you want to have these operations be relatively small chunks of work anyway. And with these kind of OMAP get operations, generally they're done in a way that loops over however many they get returned and then continues. So it's not a big deal if you change the total size for a given request, continue functioning properly.
sure. Cool. So let's see here. Okay, so it's default of 128K before, and then let's see, what is it setting it
I think
to?
it was 1024 now.
Oh yeah, okay. So much smaller then.
Yeah, and that's usually the limit that we've been kind of setting manually. I think RTW does manually set that limit of 1024 in a bunch of its uses of OMAP already. So it kind of makes sense to
Okay,
make that more general.
sure. Cool. Looks good. Okay, let's see. A couple of closed things. I had a PR that reverted the RocksDB parallel compactions back to 1. That was just kind of a shot in the dark to see if that might have been uh, contributing to the corruption issues that Igor was investigating. But thankfully, Igor had a breakthrough and figured out exactly what was going on, and it wasn't this. So I just closed that out. Um, and then another PR that closed was Eric's excellent PR to reduce the per shard entry count during bucket listing. And that's super exciting that merged. That's a really, really good improvement over what we had before. It's huge. So that's also extremely exciting. Lots of stuff that's updated here. This RBD replicated write log core codes part 1. That was, I think, a split up of a much bigger PR that previously was being considered. I think Jason is reviewing that. This one about enhancing the OSD NUMA affinity, Sage reviewed that. I think that got updated. I need to check if there was more to that one. And it looks like I object the linker stuff. Adam, did that end up getting fixed?
Yes, it did. We are just running 3 make checks to make sure it checks, and once that is, then we should be ready to go.
Fantastic. That's super exciting. Congratulations. Let's see. And then also your objection sustained looks like it got some updates.
I have finished doing a whole bunch of rebasing and doing a whole bunch of refactoring and integrating with the changes that came in while I was doing I object, and I'm currently going through testing that.
Yay. That's great. Let's see. MDS auto-tuning the MDS cache memory limit. That has, I think, got rebased and has had more updates done. I don't know if it was much more than just the rebase or not, but that's still in the works. Hifu continues to work on testing the IOU ring code. I think he did approve it at one point. I don't know if it failed or if he's just doing additional testing there. But he's continuing to do work on that. Let's see. Eric's got another PR for moving some filtering, additional filtering into the CLS code for RGW. I guess that for some reason took a real complicated rebase recently. But yes, so there that potentially could reduce the amount of work that RGW needs to do and the amount of data that's being transferred around. But with a little bit of a caveat that then there's more work happening inside the OSD, and it may make it harder to reduce the amount of decoding work and maybe encoding that the OSD has to do. Although I think it's maybe just decode, not encode, that we'd have to worry about there. But in any event, let's see. There's no movement on a couple of things. My delete range PR, I think we need to test. So I should probably get that running through Tethology soon. Another NUMA thing here for Rados GW this time. Oh, my Ono cache pinned list thing, that broke stuff. So it was reverted and now needs to be looked at again. Josh, did you ever have a chance to look at that at all?
Not yet, no. Been busy with other stuff.
Okay.
I can maybe get to that.
No worries. Me too. It's just been sitting there. So, yeah, something's wrong with it. Don't know what yet. Let's see what else. Well, I do remember wondering, though. I did look at it and was having trouble figuring out anything that was wrong with it after staring at it for a while. So I was starting to become suspicious that maybe I'm breaking something somewhere else, or that something else somewhere else is breaking because of it. But it also could just be that I'm not looking at it right, and it's my fault somewhere.
Yeah, it could be some weird edge case misusing the ref counts or something. I don't know. I have to look closer.
Yeah. That's kind of what I was wondering too, but I'm not seeing it yet. So definitely, if Josh, if you don't mind, or if anyone else doesn't mind, staring at it just a little bit, I'm not seeing it myself.
Yeah. Also, I'll try to make time for that. Thanks.
Cool, thank you. Uh, I've got a PR here for increasing the default number of RGW bucket shards. I actually did start testing that with Eric's PR. I wanted to have Eric's PR kind of merged before really, deciding on this. I think a couple of folks on the RGW side are advocating for a smaller number of default shards, like 7. I was advocating for more like 61 would be the prime number, around 64. After doing some more testing and also getting our delete range stuff fixed, it looks like the upside to more shards is better throughput or better parallelism when you have just one bucket and you're doing a bunch of writes. And then also reducing the frequency of resharding events, because now you need a significantly larger number of objects to encounter a reshard event. The downside is there are 2 downsides. One is that it does slow down bucket listing, but not nearly as much as it used to. Now it's even with 61 shards, the impact is significantly lower. It's not really even that much compared to just like 7 shards or something. So there is that. There is still some it is still a little slower, but not bad. The bigger downside is bucket creation throughput. It does decrease basically linearly. So if you're going to create a bunch of buckets, having the default be 7 shards is like almost 8 times faster than creating a bunch of buckets that have 61 shards. So there is a legitimate concern there for if a user wanted to create 1,000 buckets or 10,000 buckets or something. I don't know if that actually happens very often, but it's real. So those are kind of the dimensions of, at least from a performance perspective, of kind of what we're seeing right now in terms of what's good and what's bad. So let's see, moving on. I don't think a whole lot of other stuff has seen updates in a while. I haven't seen anything recent on Adam's sharding work. I think last I heard he was still doing some testing there to figure out why things were maybe slower at scale. But Josh, have you heard anything more recently?
Yeah, he's just gotten the tracing and stuff set up so that he can mostly track where latency is coming from. He hasn't
Cool.
actually worked it out yet, but he's in the process of experimenting and gathering data.
Good deal. I don't know. I haven't seen a whole lot on some of these other ones. I've still got my min Alex size switch to 4K PR that's sitting there. I think I was still waiting to see Igor. Did you end up making any more or newer hard drive numbers for that?
Unfortunately, not yet.
Okay.
But I'll
No
do
worries.
that.
And then I've got my refactored OSD ops PR that almost certainly is now already like super out of date because people change that really often. But it was not passing. Still, when I looked at it, there were still a couple of issues. So I wonder if I should maybe break that up into smaller chunks and just kind of, instead of trying to like tackle OSD ops entirely, maybe just tackle the things that don't have go-tos in them first, because those are fairly easy, and then move on to anything that has go-to and do that a little bit more slowly. We'll see. But it would be really nice to get that refactored because it's huge and ugly and awful. Um, okay, yeah, I think that's probably good enough. This is pretty close to where I petered out getting through these, so I'm guessing most of the rest of the stuff here hasn't seen any updates. Most of them are pretty old. So that's it for PRs. Unless anyone has any that I missed. Okay, so moving on to discussion topics. The only thing for this week that I have is that there's been a huge kind of discussion regarding transparent huge pages and stuff right now. The deal is that if you're trying to stick an OSD or the MDS or just about anything into a container, usually that container, or oftentimes the container may have a memory C group that is associated with it, where the processes are required to fit within some kind of memory envelope. And as it turns out, when transparent huge pages is set to always rather than madvise, the Ceph OSD process or other processes can end up using significantly more RSS memory than the mapped memory that TC Malloc believes it's using. Presumably, this is due to fragmentation, due to us only using a portion of a page once we freed something of a large page, of a huge page. So we've got some test results there. There's a Google Doc spreadsheet in the Etherpad if folks want to look at it. It was observed that the difference between having transparent huge pages set to madvise, essentially such that we don't use it, versus having it set to always was enough that it did end up pushing the OSD into the range where, or very, very near the range where potentially the OM killer might kill the process. And in practice, some of our QE folks were seeing that inside a container, or that the Ceph OSD process was being killed inside the C group because it was the largest contributor to the C group's aggregate RSS memory usage, which was exceeding the threshold. So there's a couple of ways this could be solved. Kind of the most, in my opinion, the most unfortunate way, but an effective way to solve this would be just to set a flag inside our global init to tell the OS that any Ceph process that uses that doesn't want transparent huge pages, and that would work fine. Patrick wrote it. He tested it. He said it looked like it was working. So I'm fairly convinced that will do a job just fine. I think though that from the kind of greater standpoint of customer experience and kind of what happens with other applications that also suffer from transparent huge pages, it'd be worth looking at whether or not having the operating system set transparent huge pages to always is really a good idea. I don't really think it is. And it turns out that Ubuntu actually had a bug report for this a couple of years ago, and they ended up switching from always to madvise. That not even counting Ceph or containers or any of that stuff. They just saw that there were a lot of applications that were suffering because of it, and then ran their own memory throughput tests and saw that transparent huge pages wasn't actually helping in the testing that they did. Anyway, that's basically what's going on there. There's a couple of bugs that I filed for both CentOS and for RHEL. We'll see if folks bite or not. So that's about it. Let's see. Eric's RGW bucket listing PR. I wanted to mention it is extremely good. It's much faster than what we had previously. There is, I think, still a little bit of room for improvement. It's returning more pages with fewer entries than would be kind of ideal. In this one test where we've got 1 million objects and a 7 shard bucket, it was returning roughly 20% more pages with fewer entries than would be kind of the ideal. So at least in previous testing, I've seen that when that happens, we're not kind of performing as well as we could. So the gist of it is it's still a huge improvement. It got merged. It's great. It continued to be great even if nothing else happened with it. I do think we can probably make it just a little bit better, but we'll see. I've got kind of an idea how we might do it. So not a big deal though. And then okay, we already talked about delete range a little bit. That's disabled for Nautilus. I think the only question now is if my PR in master to kind of make it only be invoked if there's a lot of keys, if that's enough, or if we also need to manually flush the mem tables after a certain number of delete range calls have been invoked, and there hasn't been a flush in between. I think we may actually need to do that as well, but we've got a little bit of time in master still to work that out. So probably not disable it entirely, but just figure out kind of how we can optimally use it, I guess. Any questions on any of that stuff or comments? All right.
I have one question
that's
about
all
the huge pages fix that Patrick has proposed with it, disabling it just for Ceph with a PR cuddle.
Yeah.
I was wondering if maybe Ilya knows if the huge pages used by other processes in the system could end up crowding out space for regular pages for Ceph to use in that case. Okay, at least I'm not sure in the chat. I suppose we need someone familiar with the memory management subsystem.
Ben just joined. Maybe do you want to ask again, Josh?
Sorry, I'm late, guys.
No worries. Hey, Ben. I was just curious, with the PR cuddle approach in Patrick's PR to disable transparent huge pages just for the Ceph processes, I was wondering if we could have any issues with lack of non-huge pages if the rest of the processes in the system kind of use up available memory with huge pages.
Your question is, so one of the things that concerned me and why I thought PRCTL was a good solution, that if you're doing a hyperconverged system where you have applications and and something like OpenStack or OpenShift running on the same system as Ceph, then basically just disabling transparent huge pages entirely is for making that decision for everyone, not just for Ceph. Whereas the PRCTL option basically allows Ceph to make that decision without forcing other people to. And I understand there's a lot of, I did some of the same Googling that Mark did, and ran into some of the same articles about like partners like SAP and Oracle, which I did not expect, saying bad things about it, the default. But I've been talking to other people in my group who say that there's and I'm asking them to forward success stories where there's cases where it does help. And I think that the two communities aren't talking to each other. Like the people in the Ceph community, for some reason, don't seem to hear from the people who are using it successfully. And so, I totally get your position, Mark, about it. I mean, I've run into two cases where the results were horrible with it enabled. There was a case where OpenStack was melting down a year or two ago. Just the whole cluster imploded, and part of it was having to do with THP. And then there's this recent bug where, we're hitting the C group limits, and they worked around it by doubling the C group limit. But the real answer is to manage your memory better. And turning off THP helps with that, as your data shows. But I think in the long run, there may be an intelligent use of huge pages for stuff where it could actually benefit it. But I think it's not the way that we're doing it. We have one memory allocator. Correct me if I'm wrong on any of this, but my understanding is TC-malloc is the memory allocator, and it's basically treating memory as one size fits all. And maybe there are certain kinds of cases in Ceph where huge pages make sense. Something like I/O buffers, where they're 4 megabyte buffers, and you could do that very efficiently with huge pages. But you don't want to have every single user of memory allocating, and getting huge pages delivered to them when they really don't need them and don't want them. So does that make any of that make sense?
Yeah, I think a lot of that makes sense in terms of it'd be really interesting to hear more success stories from where it is helpful. And going in the future, actually, with the Crimson work, that's looking at using a SeaStor. SeaStor is a very simple allocator, which is kind of a per core thing that allocates all the memory up front. And for that purpose, huge pages probably make sense.
Right.
It's really just the current TC-malloc based allocations in Ceph that are really harmed by it, I think.
So the question there, I guess, Ben, is the one thing I guess I have a little bit of an issue with is that I don't think anyone's recommending disabling transparent huge pages, right? No one wants to outright disable them. The argument has been to have it be opt-in via MAdvise, right?
Right. But there's a lot of apps that aren't set up to do, that MAdvise call to say, I want huge pages. And so It's going to have sort of this indeterminate effect on some applications out there, right?
Exactly. So I guess my question is it better to assume that transparent huge pages is going to help an application that hasn't said anything one way or the other, requested or denied it? Or is it better to assume that that they should not be touched, that it should just, make small memory allocations if you haven't explicitly requested huge pages? That's kind of the tension I think that there is.
Yeah, I'm kind of leaning towards you don't want to just hand out huge pages to people, by default. And
yeah,
I'm with you on that. But I think there's a lot of different points of view that on this, and just within the Perf and Scale team, I've heard people saying OpenStack uses it and uses them and so forth. But I think generally huge pages require some kind of memory management strategy to make effective use of them. You can't just sort of, if you have an application that's recycling memory, and by recycling I mean that it hands pages back to the kernel and it expects it to reuse them, then that's where you get into trouble with just handing them out at random. But I think there are cases where, when you think about it, if you have a 4 megabyte buffer, that's potentially 1,000 TLB misses just to access that buffer, and
exactly,
that can't be good. So I'm thinking maybe you need two memory allocators, basically, one for sort of your vanilla messenger type, for things where they don't really need large buffers, and then one for things that are very specialized, like large I/O buffers where you really can benefit from it. And
yeah,
I think maybe something like that might work more effectively for Ceph than just one size fits all.
Yeah,
but that's
I agree
easy
with
for
you
me
on
to
that.
say.
Yeah.
It's easy for me to say. I'm not doing the programming,
Yeah.
but
Well, and honestly too, TC-malloc has gotten like a handful of commits in the last year, right? It's not a very active project at this point. So, the likelihood of them going and doing this is pretty low. Maybe if we went in and did it ourselves or made a big fuss, maybe. But
It's bigger than Ceph, I mean, I think this problem is much more widespread than just Ceph, judging from looking at what things. I mean, I was reading about SAP and Oracle and Redis and all these different
yeah,
people that are
exactly.
having this, but I think and all of those can benefit from huge pages. So it's not like huge pages are irrelevant. It's just the way that you consume them that makes it good or bad.
Yeah, I guess that's kind of why I've been wondering if it's better to just kind of take a do no harm stance to start out with, and then let those applications kind of opportunistically try to grab huge pages when they can benefit from them, rather than kind of doing a blanket approach. But that's
Yeah. But I mean, if Ceph uses this PRCTL approach, then the problem is solved for Ceph. And then you guys can step back, and you can step back and say, all right, where does it make sense to use them in this chart? Using them in a more controlled way.
Yep, and Patrick's got a PR that does that, and it's been approved both by me and I think Josh also approved it. So it's in the works. I just think it would be very unfortunate if the end result of this conversation is we fix the kernel documentation, not to claim that M advises the default anymore. Because that's also confusing things, right?
Yes.
If the only result is that we fix the documentation and fix Ceph, that would be unfortunate in my mind. But that could be a one route that this goes.
No, I think we should continue the discussion with the kernel people, because I've been talking to Joe Mario about this, and he was sort of a pro THP guy, and I think he's starting to get that. Okay, there's cases where this really isn't working, and that there's some caution is needed. So I think we should continue that, but at least we've solved it for Ceph, and you can move forward and get on with real stuff. And so that was my only point about it.
Sure. Josh, do you want to bring up your point again? Because I think we kind of lost it.
Yeah, so I had kind of a more detailed question about the PR cutoff approach. Perhaps, Ben, you might know more about the kernel memory management here. I was wondering if, since the PR cutoff approach kind of forces the application to not use any huge pages, I was curious if you had a situation wherein you had a box which is kind of overcommitted on memory, and other processes were using lots of huge pages. It was possible there would be not enough regular pages for a non-huge page using process to use.
Yes.
Okay.
I mean, that's the problem, is that the I mean, if some other process, some other program or application is not intelligently managing its memory, then that's going to affect Ceph. That's life in the world of hyperconvergence, trying to squeeze 10 pounds of stuff into a 5-pound bag,
But I was wondering if it could be worse in the case with the huge pages from other applications, if they're using like just a few K of a huge page, and suddenly that's taking up lots of huge pages or something like that.
Well, yeah, the other programs could do that, but at least Ceph won't be doing it.
Sure.
And so that's a step in the right direction.
It's certainly better.
In a hyperconverged scenario like that, where all the applications are running inside containers, wouldn't they hit the same issue that Ceph does, though, where they'd get OM killed once the RSS total of the C group that they're in exceeds their threshold?
Right, for both OpenStack and OpenShift, or Kubernetes, I should say. There's memory limits on the applications, strict memory limits. So it may affect them, but that should limit the damage to Ceph, because they'll only be allowed to take so much. So does that answer your question? I mean, it can go into more detail. I mean, obviously, OpenStack, the VM has a fixed memory size, right? But with OpenShift and Kubernetes, there's C group limits on memory. So that it may not. It unfortunately, what happens is the application is killed if it exceeds that, as you found out.
Right.
But at least it limits the damage to the other applications that are running, or Ceph that's running on the system.
Sure.
So,
Yeah,
I think
that's kind of
it
what
is
I
interesting
assumed.
that we're kind of running into these issues just now only because we had the secret limits, whereas before we probably had the same issues, but they weren't as visible because they were crashing processes.
exactly. You might have had them, but it would be like manifest as swapping, or
Right, or it's lower performance, or
I think we did kind of see them because even if you look in like the OSD memory target documentation, when I wrote it, it was like, well, we sometimes see the RSS usage like 20% higher than the mapped memory to the process. Your
Yes.
mileage might vary because sometimes
Yeah.
we did and sometimes we didn't, and it was kind of assumed that it was probably something like THP, but we just didn't really do anything about it.
Well,
We're just like, well, this is what it can do.
Well, I mean, did I ever tell you, like 3 or 4 years ago, I was working on this OpenStack and Ceph configuration, and we were trying to do hyperconverged, and we were running FIO, and the thing was being OOM killed, and we had free memory on the system. We had like gigabytes and gigabytes of free memory, and it was still OOM killing things. Like, what the hell is going on here? And we finally wound up getting like Larry Woodman to come over, the VM developer, and he's looking at it and scratching his head. And he finally says, "Just turn off THP and KSM, and see if it helps." And sure enough, got much better. So yeah, that is a problem.
Yeah.
But I mean, if you have, like, I've heard of these systems now, like some of them that have terabytes of memory in them. You don't want to be managing that 4K at a time.
Well, yeah. Fair enough, right?
And the other piece of it is, in terms of your TLB cache miss rate, if you can use huge pages effectively, that means that you're not evicting other things from the TLB cache. So that's going to improve your performance that way too. So it's just like, there's got to be a sane way to do it that, where you use them intelligently and you don't. But I think transparent is a problem.
Yeah, huge page is not a problem, and even transparent huge page is not a problem when it's requested and the application knows in advance this is okay. It's the transparent when we have no idea what the effect will be.
That's it. So, well, anyway, I think probably beating this one to death, but I hope that helps.
Yeah.
Yeah, I think that's very helpful, Ben. Thanks. Thank you. In a more short-term perspective, I think you also were looking at some of the TC-malloc options around this, Ben. You mentioned something about the reclaim setting. I don't know if you ever experimented with that, Mark.
Not the reclaim setting. I've experimented with some of the other stuff. Primarily the excuse me, the amount of TC-malloc thread cache, but not the reclaim setting.
I had a question about TC-malloc. I was looking at the heap stats in the admin socket, and I would see there's like this central free pool that would get really big sometimes. And I was wondering, like, is that, that actually counts against the RSS of the process, right? In other words,
go
ahead.
Yeah, so it's counted in our view of the mapped memory, which also means the RSS memory. So at least we're taking it into account in the priority cache manager. So it's not like just sitting out there, but it is memory that's being used.
I mean, I saw that get as big as like 15 to 25%.
Yep.
Of total memory, and that just seems to me to be way bigger than it needs to be. If you're talking about a 4 gigabyte process and you got like, what is it, a gigabyte of, or 800 meg of this pool, it's like, why is it so big? Doesn't need to be.
There's So there's some documentation out there as to how TC-malloc works, and I don't want to even try to quote what I vaguely remember from reading through it, but I think the gist of it is that with the number of threads that we have in Ceph, especially the number of active threads, and the way that we're requesting memory and then letting memory go, that central free list ends up just getting really, really big. Josh, do you remember more details of that? It's just I have to reread it every time when I start thinking about this and relearn it again.
I think the general idea is that TC-malloc has a kind of a thread local cache for each thread, and then has a central free list as well, where it can essentially aggregate memory and then give it out to individual threads. Algorithms that it uses to do that.
I read your homework assignment, Mark, and on TC-malloc, and I think it said it like for large memory requests it goes to the central cache, and for small ones it goes to the thread local cache, something like that.
Yeah, that sounds right if I remember right. Yep.
But so you're saying that but it still seems to me like is there any kind of tuning knob for that? Because I remember seeing some various knobs around TC-malloc, and I'm trying to look them up here, but
that reclaim one that you brought up that Josh just mentioned might do it. I don't know. I mean, like if you start like freeing a bunch of stuff, right? I guess it would end up in the central free list, right? If it's like a big thing that gets freed.
Oh, is this the TC-malloc release rate? Okay, I'm going to put something in the chat window that's in this article that, and it's from this article that sent me here. And it says that it's a range from 0 to 10 and the default's 1. And I'm wondering if maybe we need to be releasing stuff a little faster, to keep that central cache from building up so much. And, that might, I'm not saying that's going to solve all our problems or some magical thing, but it might just keep the ratio more reasonable. And
I think the question, right, is if that when that central free list gets big, is it still like really rapidly grabbing stuff from it and like freeing stuff from it constantly, and that's why it's big? So even if you were like using the TC-malloc release rate, if you set that really high, would that just be churning stuff even more? Like, would it be trying to release it back to the OS and grabbing more stuff quickly, or can it like reuse some of the stuff internally that way? I don't really know. That's kind of the thought that I was wondering is why does that get big, and are we grabbing stuff from the central free list, or how how is it all working? I don't really know.
Yeah, I mean, it's hard for me to visualize that, many hundreds of megabytes of memory are needed to satisfy, all the requests that are coming in. Like this, I mean, I can see you need a certain amount to avoid churning going between the operating system and the process. But it just seems like it's not intuitive to me why it would need that much.
I imagine at least some of it is because we have lots of temporary stuff happening, right? Like you've got all these temporary buffers that are getting built up and being, you might have some memory copies happening in different places in the path. And then you've actually got the cache and, the actual write requests going into RocksDB. I wonder how much of all of this stuff you're just doing all kinds of memory work, creating temporary things that go away really quickly.
Well, I'm sure that if there's a lot of it, right? The messenger, I think, probably is the example you gave. But I mean, if these buffers are small enough, I mean, I'm wondering, like, is there something that can be done to not have them constantly released, like constantly allocated and released all the time? Are we overusing TC-malloc basically, or abusing it?
Yeah,
I think there's a
could indicate that we could be using memory pools or something else instead of TC-malloc in more places.
Yeah, Josh, that's what I've been wondering too, is if we should be using like object pools, have a big set of objects that we just reuse constantly for temporary stuff.
I mean, there's pros and cons. You can, but like a lot of object-oriented apps do that, right? Because they can embed knowledge about how they use memory that a generic memory allocator doesn't have, right? So
yeah, definitely.
So I don't know. That's
everything entirely since we have like so many variable size structures and stuff. But if we kind of use object pools with relatively large sizes, that might help things, like things for like the PG log or other structures that we allocate in the IO path.
Josh, the one that I've been kind of thinking about for a while or eyeing for a while are the transactions in BlueStor.
Yes, transactions would be a good one.
Yeah, I think you're right, Ben. I think you hit it on the head that if we do that, if we stop creating all these temporary objects for everything, that could lead to better behavior, right?
maybe. Right. I was just looking for an example. Go ahead.
If we did that too, then all of a sudden we could, instead of creating all these temporaries all the time, we could create some upfront using placement new with a giant memory allocation once. So you allocate a bunch of memory, use placement new with a bunch of objects, and then you never touch you never reallocate anything ever again.
I think right. I mean, for as long as it's like not, as long as it's not a huge amount of memory involved. I mean, why not? Why not do that? Here's an example of what I was talking about with the central cache free list. Just posted that. So in this case, we had something like it was right up against the 4 gigabyte boundary, and half a gigabyte was in the central cache free list, and it's just just made me wonder, like, well, why is that? It seems like a huge amount. Compared, I mean, I can see you might have 100 megabytes or 50 megabytes or something like that, lying around just in case you need it. But so the reason, and go ahead.
I'm curious if we could figure out like how much of that is based on like uses from the cache or from the objects in the IO path, or where that's kind of what kinds of temporary things we're freeing so often.
Yeah.
Like, Mark, do you think there's like a way the memory stats gathering that we have tracking the memory pools right now could help there?
I don't know. I'm not sure how we would associate them. I wonder if there's a way that you can get more verbose stuff out of TC-malloc. We don't expose it, but I think we can get some better stats. I wonder if there's some way we could like use the more verbose stats to actually like find out what's really in any of this.
There's a profiler. Does that help? There's a memory profiler.
I've used it before. I don't remember if I thought it was very useful or not.
I think it's useful for diagnosing what's in memory in a heap. I'm not sure if it helps with what's being freed.
What about Valgrind? I mean, it's kind of like drinking from the fire hydrant, but is that something that would be reasonable to get some insight into that, or
maybe? I mean, the only way I've ever used Valgrind is to see what's using memory, like from kind of not like the rates of allocations and deallocations, but kind of like what's using memory, right?
Looking for leaks.
Maybe you could do that. Yeah. Josh, what about LTTNG? Could we actually like start recording what's like kind of allocation and deallocation rates with it, or even just static counters, I guess. Perf
Yeah, we might
counters.
be able to set up the counters more like that with the existing like memory tracking stuff easily. Just kind of tracking like what's free, when, how big it is, that kind of stuff.
Yeah. Well, I was even thinking like how how over a period of time, how many creations of different objects we're making, like transactions and temporary PG log stuff and other temporaries. What are the rates of these things that we're creating?
Yeah, that'd be really interesting. I think we probably could add that to the existing memory allocator stats.
That would be interesting. It's a good idea, Ben.
Ideas are cheap. It's the hard part's doing it. And but I just the only reason I brought it up is because we focused entirely on the THP discussion, and that is relevant. But this is like another piece of it, maybe. That
Yeah, it's a good idea because I don't think we've really taken a close look at memory use in Ceph at this level in a while. And there's probably some low-hanging fruit we could tackle there, like Mark was talking about with the transactions or other things.
Probably the closest we've done is the work trying to figure out if there's any way we can reduce the amount of memory copying that we do in the bufferless that Radek was looking at, and I was kind of looking at a little bit too.
Yeah.
But
memory
kind
copy. What do you mean by that exactly?
So when you have a buffer list, right? The idea behind it is that you have a bunch of different contiguous buffers, but overall you might not have a contiguous amount of memory, right? Or space of memory. You might have all these other disparate things. And so when you're doing things like appends, how does that actually work? What are you doing when you append something? Are you appending, if you have just like a ton of tiny little buffers, do you want to have a big fragmented buffer list that has pointers off into all these different regions? Or at some point, do you make the decision now we're going to just like take all this stuff and put it into a contiguous range of memory that we now are newly allocating? Or up front, do we allocate a bigger amount of memory so that we can do little appends and then not have to reallocate memory? And so what's the scheme behind all this stuff? And Radek looked into this and I looked into this, and it got into like things like, okay, can we use small vectors, basically like, vectors that also have like a certain amount of dedicated memory up front that you're using to, yeah, exactly. But that ended up not working out because we were in reality, and we weren't storing data, we were storing pointers anyway, so it didn't matter. It was all fragmented anyway, no matter what. But the gist behind all of this is just there's different approaches, and finding the right approach to all of this stuff for multi-buffer management is really tricky and difficult.
I get that. So like one thing, I mean, that I'm just curious about is, I don't know the Ceph code base that well, is are you doing scatter gather I/O when you do I/O to, for example, TCP sockets, or when you do I/O to block devices, or are you doing like a single buffer at a time?
Josh, I don't know how the async messenger works at all. Do you?
I think I don't think we're using the scatter gather APIs so much there. There is some more recent work to use IO ring though, just to reduce the overhead of the syscalls.
Yep, and that does the scatter gather, I think, right?
Yeah, I think that's right. So
because
there's we're probably adding to scatter gather at that point.
There's like a system call, I think it's called read v or write v, that it basically you provide it an array of buffer pointers rather than a single buffer pointer. So in theory, if you have that, then maybe you don't need to, coalesce your different pieces of the buffer into one big contiguous piece, because you can just pass it to, the socket or the block device that way. Is that?
Yeah,
I'm just
yeah.
curious if that was part of the discussion.
That's certainly been part of the discussion for Crimson for a future optimization there. The idea being that, like you said, you don't need to have like one humongous buffer necessarily, but you need to keep the same set of buffers, use the vectorized calls in both network and storage stacks.
That
All right.
reminds me of there was a PR I made a while ago that your topic just reminded me of.
Oh, Ilya says, I think we do scatter gather IO. So, okay. So I guess
Okay.
that answers that question. So, I mean, then if that's the case, then is there, I guess my naive question is, well, then why try to massage the buffers that way? Because you're just going to be able to send them in a single call anyway. So maybe I'm missing something there.
I think this is maybe more about the like encode decode overhead of like trying to add more to buffers within the OC itself, rather than when we're reading and writing to storage or off the network. So it's kind of trying to reduce the CPU overhead and of those extra allocations, and especially for cases when trying to
So if you're doing like blue store compression or something like that, you need to,
or just for our on-wire formats when we're encoding and decoding to and from the on-wire versus in-memory, or on-disk versus in-memory.
We use bufferless everywhere, like for anything that's basically, encoding something and then later decoding it for some other reason somewhere else. It's like bufferless is kind of like the default thing that ends up being used for it.
Okay.
Maybe overused, honestly, from my perspective, but it's definitely highly used.
Yeah, I think lots of folks would be happy to not use it as frequently, but it's tough to get rid of it everywhere.
Yeah.
Kind of code base.
Well, I mean, it's the old thing with performance that typically, there's the old 80-20 rule, or the probably more extreme, where, there's a very small percentage of code that takes most of your time. And so probably don't need to change it everywhere. Anyway.
Yeah, sure. Just path.
All right. Is there any more? Is this conversation? I think we pretty much covered all the ground that I can think of. But anybody else got anything they want to add? Or
Don't think so. We're out of time too, so this is probably a good place to wrap it up.
Oh, yeah, we are. But thank you for a good conversation. And
thanks for joining, Ben.
Yeah, you guys take care.
You too. Have a good week, guys.